So what is index? Just think. For index, just think. You have a textbook. You have a textbook and you have contents. Index of contents. You know, right? Index of contents.
Yeah, they like a
Yes.
table of content.
Yeah, index of contents and all level of contents. So in the very first or second page itself, you will see the index of contents. It will tell the list of units under the chapters and page numbers. So page numbers are given. So it is easy for you to search for any chapter. You directly jump onto that particular topic. Correct? You no need to turn each and every page to find out whether what the topic you are searching for. You can go to the index, you can find the topic, and you can jump onto the particular page number. Yes or no?
Yes, sir.
Yes. So that is index. Okay. And next, you book a train ticket. Okay. Let's say you book a train ticket. I don't know nowadays, it's been many years I traveled in train. If you book a train ticket, you'll get the train ticket number, right? Name. They used to stick on the compartment, or what is it? They used to stick on that compartment. Okay. Train compartment. Where is your seat? You do you know that? Have you experienced this anytime?
Yes, sir.
Actually, during the days, we used to get only uh, which compartment is that's all. They won't give the seat numbers. Okay. So that day when the train arrives, so we have to see which compartment we belongs to and which seat number we belongs to. We have to check there and then get into the train, like a bus seat number or like a flight seat number. Correct? So they are giving a
Yes.
direction. They're giving a direction. Okay. So that is one thing. And if you are explaining something to your friend, okay, let it be you are explaining on a big screen, okay, and you want to point out something, you are explaining, let's say, India map or world map. You are explaining a world map and you want to show where is Nepal. What you'll do? You are going to show with the help of your finger, see there, that is the place. Yes or no?
Yes.
So that is what index. These are all whatever I told are indexes. Index is a pointer. Index is a pointer where exactly the value is. Index is a pointer where exactly the value is, which helps in reducing the time. Coming to the book, let's say you have index of contents. Because of that, you can directly jump onto the page, whichever you want to, or which topic you want to, very easily. Imagine if there is no index of contents and there is a textbook, that's all. No contents are given, no index is given. Contents are there, no index is given. So, how much time it will take for you to search to find the topic? It might be in the last page or last but page, it might be in the third page, it might be in the 50th page, don't know. You have to keep searching, 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 searching. Yes or no? The same
Yes, sir.
example in your notes, in your college notes, or mostly in your 10th, 11th college graduation days. If you have written your notes properly, and if you want to find out a topic after 3 months, okay, what you will do? You keep on searching the book. Yes or no? Because there is no index in the notebook. Whatever we have written, there is no index. We have to keep on searching. And I used to hold the paper for few topics which are important or which are frequently visited. I used to hold the paper so that we can directly jump on it. I used to. No, because there is no index, right? I used to fold a paper, a corner of the paper, so that directly we can jump onto the particular topic. Got it? So without index, what is the problem? You got it? Yes, no?
Uh, does it take a long time to find out any topics?
Correct.
Yeah.
Takes long time to find out the topic because we don't know where exactly in which page number it is. Okay?
The same thing on the library tree, yeah? As we use
What is it?
in the library tree, same thing, yeah? That's called index
Like,
also.
same. Now, what we are doing, we are coming to the database. Correct? In database, we have table. In table, we have data. We have a lot of records. Lot of records. I want to find out a record where employee ID is 379. 379 employee ID I want to pick. We have inserted records zigzag 1 to 10, 100 to 300, 800 to 900, 500 to 200, 500 to 600. Like the zigzag order we have inserted. ID also we only created. So not auto-generated. We created like this. Now I want to find the 369 or 379. It's in zigzag order. It's not in ordered format. It's not sorted first of all. Okay. It's not sorted. So how much time it will take to find out 379? Take lot of time. Correct? It is not sorted in proper order. If you see the textbook, it is sorted order. Correct? Index is a
Yes.
sorted order in your textbook. Yes or no?
Yes.
Yes, sir.
Yeah. So as it is a sorted order, it is easy for you to find out where is exactly the particular topic. Agree?
Mm-hmm.
Yes, sir.
Whereas if your data is not properly sorted, and if you want to find out, it will take a lot of time. Yes or no?
Yeah.
Yes, sir.
So index is an ordered list of values which are taken from your column, that is ID column. It may not be a numerical. It might be name column also. It might be email ID also. It might be mobile number also. Basically, it has to be an ordered list of values. It has to be sorted. It could be in ascending or descending. It has to be sorted. Ordered list of values taken from one column or multiple columns, which are considered from one column or multiple columns in a table. And these are organized in a B tree in the back end. These are organized in a B tree. What is B tree? B tree is called as balanced tree. You may binary tree you may think because binary we have learnt. So here it is called as a balanced tree. Okay. Do you want more example on index? Let me know. I can give more examples or more explanation also.
No, sir. I think it's clear enough now.
Sorry, you said they are organized in a B3 or B
I'll
tree?
explain. I'll explain.
Sure.
B tree, balanced tree.
Understood.
Okay. Okay. So this is the index is the object we call. Everything is an object in SQL Server. Index is an object which helps us to find the rows faster without scanning the whole table. So with the help of index, it will not scan whole table. It will directly pick whatever you want. Let's say if there is no index, what happens?
Or are you sharing your screen? Because we are.
No. I'm just explaining. Okay. If there is no index, what happens? It is going to scan whole columns. I mean, whole data. Whole data it is going to look for. You're getting me?
Yes, sir.
You have 100 records. One moment. I would like to explain. Just a moment. So your question will be like this. Your what to say? Interview questions might be like this. What are indexes? Explain indexes. What are the types of indexes? We'll explain all this. So the question will be in a different way. What happens when there are no indexes on a table? And you are searching for data. What happens if there are no indexes on a table? Correct? So we are looking on the positive side. Okay, index is this, index purpose is this, advantage is this, it will fetch the faster. So it means that if indexes are not there, it won't fetch faster. It is slow. That is simple answer. But what happens exactly? Can you tell? You are searching for data and there are no indexes. So what SQL server do is SQL server scans the entire table for finding the matched data. I have searched, you can find out again in the table. Okay. So there is no index. What it is going to do, it is going to scan the entire table to find, okay, first row, Eugen is matching, no. Second row, Eugen is matching, no. Third row, Eugen is matching, no. Like that, it is going to compare each and every value. So this is called as table scan or also called as heap scan. You're getting me?
Yes, sir.
Table scan means if there are no index, the search is applying on the whole table. It is going to search whole table till it finds. Let's say you have 100 rows, I told. It found Eugen in the 95th row. So the 95 times it is checking Eugen is there, Eugen is there, Eugen is there or not. Clear?
Yes, sir.
Getting me?
Yes, sir.
So if there is no index on that particular column, SQL Server cannot jump directly to the row. Like how I told in a notes, it is going to come. You are going to compare each and every page. What are the topic you are looking for? Let's say you are looking for a topic called as stored procedures in a notebook. From page number 1, you are going to see stored procedure first page, no, second page, no, third page, no, fourth page, no, fifth page, no, and so on. Correct? So it checks row by row. It checks rows one by one, not whole at a time. So table scan means it is going to go to the row 1, compare, row 2, compare, row 2, compare, row 3, compare. Eugen is there, row 1, Eugen is there, row 2, Eugen is there, row 3, and it compares till it finds in the table. So it found in the 95th row out of 100. Okay. Internally, it is going to do a table scan. Clear?
Mhm.
Okay. Why this is slow? Why this is slow is it has more IO, input output reads. It is every time checking with each and every row. So it's a more input and more output reads. And more memory usage also will be there. Okay. And CPU comparisons because we are comparing, right? The CPU is comparing. This is called as high CPU for comparisons, higher CPU for comparisons. Slow response time because it is not finding blocks other queries longer because it is using more memory. It will stop other users to not execute or slowly execute. Okay. So let's say if you have 100 rows, that's fine. If you have 1 million, 1 million or 2 millions or 10 millions of rows, what happens? It has to read many portions of the table. Many portions means because 1 million of data, if your value is there after, no, what to say, 5 lakhs of records, how much time it will take to search? Exactly like without index, you are finding finding the topic in a notebook where there is no page numbers. If you have an index, it is easy that alphabetical index or table index. It could be alphabetical order index or it could be topic wise index. Any index which will help us to jump into the page number. Are you clear about the topic? Index and without index, how it works?
It's clear, sir.
Yes.
Okay. So now let me share my screen. So this is a notes index. Index is an ordered list of values taken from one or more columns of a table and organized in a B tree. In SQL Server, we have two types of indexes. These are standard indexes, okay? Under that, we might have multiple names. These are the standard indexes. We have two types of indexes, cluster index and non-cluster index. Cluster index is the one which is created on a column where data does not have duplicates and where it does not have null values. If you want to create a cluster index on any column or any combination of columns, let's say any column, one column, ensure that that column does not have duplicate data and also ensure that that column does not have null values. In simple, whenever you create a primary key, automatically cluster index gets created in the backend. If you remember, this statement, or if you even remember the statement, I said that two things. I'll tell this point later. Okay, just read it. I'll tell this point later when at the end of the all topics when we touch indexes. This is the statement related. Once primary is created, in the background, cluster index is created on the same column. Got it?
Mhm.
So you can check if you want. If you have created primary key on multiple tables. Just go to the table, press Alt F1, and you scroll down. You see primary key will be there. At the same time, you also see cluster index on the same column. You can check if you want. You don't check. Are you checking?
Yes, sir.
Check any table.
Denise, what?
So if you see here, there is a primary key created. See, primary key created, primary key constraint name on this column. Agree? On the employee ID, we have created a primary key. Just above C, there is an index also created, and that is cluster index. On the primary key only you can see cluster index, clustered index, clustered unique primary key located on a primary, that is ID column. Who created this? This we created during the foreign key column, foreign key topic. At that time we don't know what. At that time we don't know what is index. Okay, but I didn't create in that time. During that time, it's automatically creating the primary key. Do you agree?
So
Yeah.
now you find out this one, this table, this bottom one,
Alt F1.
Alt F1.
Select the table and do Alt F1. Observe this. Please observe. I am creating two tables. One table test March. ID name. Other table test April. ID primary key and name. Got it?
Mhm.
Let's see the difference. Now I'm selecting this, executing this. Okay, access restricted to create tables. So let me disable this. So I'm creating a table. So table got created. Now select this table, test match, Alt F1. When I press Alt F1, I'll get the description of the table. You see ID is there, name is there, identity, no, I didn't create any identity. That's all. There is no any primary key. Agree?
Yep.
Everyone?
Yes.
I want chorus. I don't
Yes,
know.
sir. We're checking on it.
I got it, sir.
Okay. Next. I am creating another table, April, test underscore April. So table got created. I am selecting this table and pressing Alt F1. So same test April, ID name, okay. Identity, no identity, we didn't create any identity. Okay, you can leave this. See here, forget about this for a moment. Primary key constraint is there. Constraint name, primary key. This is the name of the constraint name which is creating automatically name of the constraint. And it is creating on ID column. Agree? Now, associated to this primary key, you can see it's a clustered automatically. Associated to this primary key, you have an index name created. Name of the index also got created. It's a clustered index on ID column. Why it is creating cluster index? What is primary key? Primary key means
Unique and normal.
primary key can be created on a column, and in that column, duplicates, it won't allow duplicates, and it won't allow null values. Correct? Primary key says I don't allow duplicates, I don't allow null values. That's what primary key says. Clustered also says same. I can get created. Cluster index can get created only on a column which does not allow null values, which does not have which does not have duplicates, which does not allow duplicates, which does not allow null values. Why? Because this is the reason. Whenever you create primary key, automatically cluster index is getting. So the features are same for both of them. Are you clear?
Yes, sir.
Okay. Well, good. So fine, cluster index it is automatically creating when we create a primary key. Now in this case, what to do, sir? You may put a question. If this is the one, automatically cluster index is created. Now I want to create a cluster index on this column. Explicitly, I want to create now. Now I want to create. So this table has already 100 records. Already imagine this table has already 100 records. Now I want to create a what to say? Now I want to create index on this. You are getting me?
Yes, sir.
Yes.
Got it? Now I have 100 records already in the test March. I have already 10 records in test April also, let's say. When you compare the 100 records, it's not a big deal. Okay, so it will run faster only. If you compare, there are many records between these two. This will be very faster compared to this. Why? Because this has a cluster index. Okay. Now, so let's start from test underscore March. You have 100 records, correct? I want to search some record called as 71. Okay. What it will do? It will do, okay, 71 is this, 71 is this, 71 is this, 71 is this. It is going to search for 70 times. Unsuccessful output 70 times, and 71 is a successful output. Okay. If I want to create a cluster index on this, There is a syntax we can create. That is one thing. Okay, let us create. Create cluster index name on table of column. This is a syntax. So create cluster index idx underscore id. I'll just give this is a column name. Cluster index, right? So ca underscore I'll say cluster index underscore id. This is the name of the index on test underscore march on column id column. So that's all. Executed this. Command got executed successfully. Okay, now if you go and select the table test match alt F1, what happened here? Cluster index is created on the ID column and the name is CA underscore cluster index underscore ID. Got it? How to create cluster index? Are you clear?
Yes, sir.
Okay. There is one more thing called as cluster index. How many cluster index we can create in a table? How many primary keys we can create in a table?
Just one.
One. Yes, there are rules. First rule itself says you can create only one primary key on a table, and that primary key can be created on a single column, or that primary key can be created on a multiple columns. If a primary key is created on a single column, simple primary key. If primary is created on more than one columns, more than one column means combination of columns. That is called as composite primary key. Do you remember this?
Yeah.
How many of you don't remember? Let me know, I'll do a revision. How many of you don't remember this? Everyone remembers it.
Yes, sir.
Okay, good. See here, primary key is a collection of one or more columns used to identify a row. This is used to identify a row, basically primary keys. That's why on IDs we generally create the primary key. Primary key is defined for a column. You can create primary key on a column or for combination of columns. If you create primary key on combination of columns, that is called as a composite primary key. And if you remember, we have created this separate table and shown you how to create a primary key. Which table it is, do you remember? Silence means I don't know, or silence means everything I know. I am not clear on it.
So what was the question?
Oh, don't remember, sir. I mean,
Yeah. So we created a composite primary key. Do you remember which table we created?
No, sir.
No, I don't remember.
Okay. Composite primary key we created. That is nothing but a primary key which is created on combination of columns. Okay. We created with an I shown with an example also how to do. That is author books or it should be orders, either of it.
Book author.
It's not there here. I was not sharing the queries with you, earlier queries. Primary key all I didn't share. Foreign key is there. Oh, okay. I don't have that to show. So we created a primary key on composite,
Is
I
it
mean, two columns. For
is it a
example,
band member? The
hmm,
musician band member, I think.
create table orders. So if you remember, order number was a foreign key. Remember this during normalization we did this references order table, orders table of order number, or product number, integer, products table, product number. Okay. So there are two foreign keys. Order date. I want to create a primary key on top of these two columns. If it is a one column, you write simply here itself primary key. If you want to create primary key on combination of columns, we write like this. Primary key of order number, comma, product. We have seen this product number. Like this we have written. So this is composite primary key. It is created on top of two columns on this table. Clear? Now we compare. Select this table which has cluster index, which has a primary key. Same data is there in both the tables. Okay. So this is the output. And this is the output. Now let me select where it is. It is not coming. I am selecting the test match which does not have the primary key. Now see the difference. Able to see my screen? Everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
This is same. This is same. This is same. No entity column defined. Okay, because identity of 1 comma 1 we didn't define. Row GID is fine. Primary is fine. Index name is also fine. It has defined its own name, but we have defined our own name. This is also same after creating index. This is not there in our table because we don't have primary key. This is the April table is having primary key. This table is having primary key, whereas our mass table doesn't have primary key. So it is not showing it. Clear? Clear?
Yeah.
So now we'll
Yes.
do one. We'll do one thing. This test April insert into test April values of null comma name 101. So I'm trying to insert null value in the April. What it is saying? Just a minute. What it is saying? Cannot insert null value into the ID column because column does not allow null values. Fine. Now let us do this in the March table. What happens? It doesn't have primary key, but what happens? Let's see. So it is working. Clear? Let us try to do one more time. I'm not sure. Let me check. These things are like trial and error. It is working. So now this is the index, right? Let me do one thing. Drop index name. That's all. Drop index name. Okay, on table I have to specify on table. Okay. So index is dropped. Index is dropped on the test match. Agree? You can see here index is not there. I am trying to create an index now because it has null values. Let me try to create an index on the ID column. It's working. So I have to correct my notes if it is. Cluster index, I didn't tell anywhere. Okay, fine then. Fine. Yeah, notes is correct. So you got it right. Cluster index you can create on a column even there is a null value. Let me try to have a duplicate and see. Again dropping the index. Now I'll keep it here 100. It should work. Let's see. Now I'm creating the index. Yeah, it's working. Clear? Any questions? So
No, sir.
cluster index does not act as a primary key. Cluster index can be created on any column. Cluster index can be created on any column. But whenever you create a primary key, it also automatically creating a cluster index. Clear?
Yes, sir.
Prashant, answers. Your question is answered.
Yeah, yeah.
Okay. So that is cluster index. Cluster index can be created on combination of columns also. It means it can create on 2, 3 columns also. So example, I'm dropping this cluster index. I'm creating a cluster index underscore ID underscore name I'm saying. Even combination also I can give. Now the cluster index is created on combination of columns. Okay.
How many columns can we put in this one?
I don't know the highest number, but generally we give 2, 3, 4 columns max. Generally. Because whenever you create that index, right, it is going to apply the index on this combination of data. Okay. And it has to
Yeah.
order the data accordingly. So it will take time. If you create index on, let's say 10 or 20 columns, it will take more time to sort the data across all the columns and show you.
Yeah.
Okay.
Yes, sir.
Okay. So this is about cluster index. So generally again I say cluster index automatically gets created on a primary key. In mostly in most of the tables this gets created automatically. We don't create it specifically from our side. Okay.
Yes, sir.
Clear? Okay. There is one more concept that is non-cluster index. non-cluster index. So now, whenever you want to search the data, select star from employees, employee. There is one more table, right?
SQ.
Employees SQ. So whenever you want to search the data, it is not only on the ID column. Sometimes you might search on the employee name column, or you might search on the, what is that, email ID, mobile number, passport number, which are not duplicates for employees or any other data, correct? Email ID will be unique for each and every user or each and every employee or each and every student, each and every patient. Similarly, passport number will be distinct for each and every user, each and every employee, each and every customer, each and every student.
Sometimes phone number too, yeah.
Hmm?
Sometimes we use phone number too.
Phone number 2, you'll have a separate column, right? Phone number 2. So whatever we work with very small set of tables, like columns are less. But if you go to actual real-time tables, you'll have a mobile number 1, mobile number 2, or else primary contact number, or alternate contact number. Okay. So if it is a second mobile number, you are going to enter into the alternate contact number, not in the primary contact number. Correct? So basically the primary contact numbers, if you see, those are all distinct. There won't be duplicates in it. Correct? Cluster index, we will create only one in a table. That we will go with ID column, most of it. And if you want to still create indexes on other columns to read your data faster, let's say you are using mobile number many times to search where conditions or join conditions. Okay. So better to have an index on mobile number so that your data retrieves fastly. Correct? Yes or no?
Yes, sir.
Correct.
Mhm.
So better to have a index on email ID so that your search will be faster. Better to have a index on the passport number so that your search becomes faster. So if you want to have an alternate index apart from cluster index, what is available? Option 1, in a table you can have only one cluster index. You cannot have multiple cluster indexes. But if you want to create more than one indexes on a table, like a mobile number you have, a PAN card you have, sorry, a SSN you have, passport you have, okay, email ID you have. On such columns you want to create indexes so that your search becomes faster. These are the mostly or globally used identifiers. If you go to any shop, any supermarket, first time they'll take your mobile number. Yes or no? Why? They want to identify you with a mobile number, not with any other ID. If you go to your government offices, they may ask you SSN, correct? Because they can easily identify you using SSN. If you go to, if you are filling any forms, like if you are booking tickets or if you are booking movie tickets or train tickets or flight tickets, they take your mobile number as well as email ID also. Why? Email ID, they are going to send you the ticket, correct? So
Yes, sir.
email ID is also required. So on such columns, when they are searching, they should able to identify globally, not only in your office. So at that time, these columns are to be given as or should be assigned with an index to search faster, right?
Yeah.
Yes.
In a table, you can have only one cluster index, but in a table, we can have more than one non-cluster indexes. So we are going to create non-cluster index on this. We are going to create non-cluster index. How to create non-cluster index? Syntax is same. Syntax is same. Create non-clustered index index name on table of columns. Got it? So now let us decide where we can create. Select staff from customers. So if you see city column, we may use city column to identify, mobile number to identify. Okay. So let me create a mobile number. Okay. Create non-clustered index on mobile column. Create non-clustered index NCI underscore mobile. I'll call non-clustered index mobile on customers table of mobile. So non-clustered, it is one word, I guess. Yeah, one word. Okay, non-clustered is one word. Now mobile number is wrong column. I think C mobile it is. Yeah, C mobile. Customers mobile. So index is created. Now select this table. Alt F1. You can scroll down to the end. You can see already primary key is there. So foreign key is there, primary key is there, clustered, and unique constraint is there. Unique constraint is there already on mobile. Oh, then no need of creating. Okay, let me drop this index. What happens, I'll tell you. So if you see the customer table, already there is a non-cluster index. So whenever we create unique constraint, automatically non-cluster index is created. Even this point we discussed, but I told that we'll discuss about this at the end. So if you see here, unique constraint, once unique constraint is created, in the background, unique non-cluster index gets created. Unique non-clustered means in that column does not allow duplicates. Okay. In non-clustered, there is non-clustered as well as unique non-clustered. Unique non-clustered means which you are creating on a column which does not allow duplicates. Okay. So unique non-clustered index is already getting created whenever you are creating unique constraint. So no need to create additional constraint. Additional index. Okay. Now let me create an index on index on city column. Create non-cluster index city. So on city column there is no index. You can see on there is no index on city column. This is primary key index. This is unique constraint index. Now I'm creating an index for the city column. Column C cities. So now you can go and check the customer table. You can see here a new non-cluster index got created on city column. Clear?
Yes, sir.
You can have multiple indexes, multiple non-cluster indexes in a table. There is no any restriction. Around 250 you can create max. You can have more than one non-cluster indexes in a table, but we don't create more. See, generally in a table you might have some 20 to 50 columns in real time. You can create some 3 to 5 non-cluster indexes and not suggested to create more than that. Why? Because either it is a cluster index or it is a non-cluster index. What it is going to do is it is going to sort your data on the column whatever you specified. Okay. Then your question will be how this works. I'll explain you. So you got how to create the indexes. You can have non-cluster indexes more than one in a table, whereas cluster index only one in a table. Clear?
Yeah.
Yes, sir.
Okay. So now,
Sir, one short
yeah,
question. There's on which
yes.
condition that we create a cluster index and non-cluster index?
Where come again?
In which condition we have to create a cluster index or non-cluster index?
See, cluster index is suggested to create an ID column. Okay. Non-cluster index is created on a column where you read your columns multiple times, where you are using those columns multiple times in the where conditions or group by clauses or joins. So the columns which are mostly used are where conditions. Okay. So I use city column multiple times in the where condition. Group by clauses, I use city column. Select statement, I use city column. Most used columns suggested to create non-cluster index. Obviously, cluster index will go to the identity column. Okay. Most of the times we will not get chance to create a cluster index. Why? Because along with primary key, cluster index gets created. Okay.
Okay, sir. Thank you.
Okay. Now we'll see how it works. How cluster index or non-cluster index will work. So let's say you have 1 to 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 50, 51, 52, 53, 4, 71, 72, 73, 74, sorry, 95, 96, 97, 98, 99, 100. So there are the values from 1 to 100. Okay. You have values from 1 to 100. Imagine like this. Oh, you have values from 1 to 100. Now I'm searching for, let's say 66 value. I'm searching for 66 value. What happens? It is 66. No. It is 66. No. 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 Somewhere here it will identify 66. Correct? So 66 value is getting compared with each and every value after 65 searches. After 65 searches, it is going to identify the 66 value. Clear? Yes or no? This is
Yeah.
without index. This is without index. After 66 searches, it is finding the value which you are searching. Without index, this is how it works. Okay. Now with index, how it will work? So you are looking for 66. Your data is classified into like this 1 to 100. To here, 100 here. Here 1 to 25. 6 to 51 to 75. 76 to 100. Similarly, 1 to 12 and so on. Okay. 1 to 12 and 13 to 25. This is balanced tree. Okay. Now finally, you'll have one here or the leaf node. This is a leaf node. Okay. 2, 3, 4, 5, 6, 7, 8, and so on. You'll have 100. These are called as leaf nodes. Clear? Now you are looking for 66. You have index. So 66, what it will do? 1 to 1, 66, right? 66 falls under here. No, it will come under here. It will fall under here. No, it will come under here. It will come here. It will come here. It will come here. And finally, you have 66 here. It is finding the shortest path to find your data. Yes or no?
Mhm.
Getting me how index works? No, yes.
Yes, sir.
Instead of searching each and every value without index, if you have index, it is going to search directly in the shortest way to find your value.
I understand, sir.
So here, 50% of the data it is not searching. Here, 25% of the data it is not searching. Here again, some no, I can say 10% of the data is not searching. Here again, some other data it is not searching. It is searching in the shortest way. Correct? Agree with me?
Yes, sir.
Got it, sir.
Yes, sir.
So it is avoiding lot of portion of the data to search. So 50 here, here 25, 75%, here let's say 10%, under 5%, okay, 85%, 90% of the data it is skipping searching. It is just searching in the 10% of the data. Yes or no? You take any number, it is same. You take 5, it is here, it is here, it is here, it is here, and 5 somewhere here it will come. The first level only to 5. So you are almost excluding lot of portion of data and comparing. So this is how B tree works. Now coming to, this is a leaf node. What does this leaf node contain? If it is cluster index, if it is cluster index, so cluster index, what it will have is, if you are using a cluster index, leaf nodes have the actual data. Let's say, if I ask, where is Eugen? Index will take me to where Eugen is. It means if Eugen is at home, it will take me and show here is Eugen to his home. If Eugen is in office, when I ask if Eugen is in office, index will take me and show Eugen is in office. See here, like basically it is going to show me Eugen wherever he is. Wherever he is in front of him, it is going to drop me. it means that it is going to drop in front of the value. It is going to show exactly where the value is. Okay. What does non-cluster index will do? Leaf nodes have the address of the data. So again, if I ask where is Eugen, non-cluster index is going to tell it is not going to take me to wherever Eugen is there. It is okay. It is going to say Eugen is in home. It is going to give the address of the home. That's all. Eugen is in office. It is going to give the address of the office. It's not going to take me and drop me in front of Eugen. It's just going to give the address of the Eugen. So leaf nodes will have the address of the data, whereas cluster index leaf nodes is going to have the actual data. You got the difference? So coming back to our notes. See here. You can take this example. This is going to be a cluster index, only one. Mobile number, non-cluster index. Email ID, non-cluster index. See, mobile number and email ID, it's a unique non-cluster index. Unique means no duplicates in this. This is non-cluster index. This is unique non-cluster index. Unique non-cluster, unique non-cluster. Okay. So unique non-cluster, just we are going to add a unique before the non-cluster. So we created non-cluster. Just before that, we will have unique. This is what we created. We are going to have unique before, so that it becomes a unique non-cluster index. If we want to drop the index, drop index name on table name. I will give that. Okay. So similarly, students, here ID cluster index, no primary key, but still cluster index. Here is already there is a unique constraint, unique non-cluster index. Okay. So differences I told already. Here you can see the differences. We can have only one cluster index. We can have 249 non-cluster indexes. Both work on the leaf tree. Actual rows are arranged in the same order as index. So actual rows may not be arranged. Why? Because it deals with the address, not with the value. B tree contains address of the rows. Here B tree contains the actual rows. Actual values the B tree is going to have. Here address it is going to have. See here. If you are looking for 200, okay, out of 1000, you are looking for a value 200 out of 1000. Your data goes like this, and your data found somewhere here or somewhere here, whatever. So basically, if the cluster index, if this is a cluster index, B tree will hold the actual data. If this is a non-cluster index, B tree will hold the address of the data. Okay. Address of the data if it is a non-cluster index. So cluster index gives a better performance compared to non-cluster index because it is only one and it holds the actual value, not the address. Advantages are faster retrieval of data, improvement in the search process, search execution. When we have insert, when we are doing insert statements, better we disable the index or drop the indexes. Why? Because if there is an index and you are inserting multiple rows, it tries to sort the data immediately. Okay. So it will take a lot of time to insert the data because whenever you are inserting, it is sorting the data. So if you have a lot of inserts or if you are running a ETL program, if you are running a ETL program on a table where there are indexes, disable the indexes or drop the indexes, run the ETL load, your ETL will be faster, and then create the indexes or enable the indexes. That way it is good. And after creating indexes or enabling indexes, it is always a good practice to reorganize the index or rebuild the index for better performance. Why? Because you have disabled the indexes. You inserted lot of data using ETL. Let's say you inserted 10,000 records using ETL. After insertion is done, you are going to enable the index. Because we inserted 10,000 records, the order list has to get updated. Yes or no? The data should be sorted so that your search becomes faster. You have just inserted 10,000 records and we didn't do the order list. We created or enabled the indexes. What is suggested way is you have to reorganize and rebuild the index for better performance. So in this case, if you go here, you see customer table. There are indexes here, which we just created. Okay, where we created on the customer CCTV created, right? Which database? 26 only, right? Let me refresh it. Where it went? Okay, not this table, about table, sorry. Indexes. You see, this is unique non-clustered. This is simple non-clustered. You can see the name itself. This is unique non-clustered. This non-clustered. This came along with the table. Whenever you create a table, you create a unique constraint along with the this I created. Now right click on this. You have an option to rebuild. Okay. Reorganize. Why reorganize? Your data, you insert a new data and you just want to reorder your data so that your search becomes faster. So if you do that rebuild and reorganize, your search becomes faster, your query performance will be faster. Are you clear till now? Any questions on indexes? Yes, no.
No, sir.
No questions.
So I told about table scan. So here if you see, we know about table scan. Table scan, it is going to do total table scan in order to fetch your data if there is no index. Total table scan is done. Yes or no?
Uh-huh.
Agree?
Yep.
So we'll be discussing about these things, difference between scan, seek, table scan, index seek, which are like for interview questions. This I'll give this table also. Okay, for now we'll stop here. What I suggest you to is create indexes on tables where you don't have primary key also, and create non-cluster indexes on existing tables, and existing tables where you don't have unique non-cluster index, you can create unique non-cluster index also. Okay,
Mhm. So I
fine.
have a question here
Yes, please.
about the non-cluster, right? You said a non-cluster gives us the address of the uh, data.
Correct.
So what do you mean by that? Like, can you give us an example?
Address means, so let's say you have a page number in the what to say. Usually you'll have a page number. Pages will be there in SQL Server. You know that?
No.
In SQL Server, where your data is inserting in a table. Correct?
Right.
In table, you'll have pages.
Okay.
Table
I
you'll
didn't
have
know that.
pages. Why? Because you have lot of data. Okay. Like how you are inserting in a table, in a notes, it will be organizing in the same way in a table. In a table, there will be pages. Okay. I may not see that. How we can identify is whenever whenever you execute, it processes the data, right? While processing the data, it will fetch few data and it fetches few data later, slowly. Once you keep scrolling, it keeps coming data. So that is because the data is organized in pages. Okay. So come back to your question, please. Missed it.
Yeah. I mean, non-cluster index
Uh,
gives us the address of the data, right?
correct.
Yeah.
So
Whereas,
this pages will be there, right? Whenever you are looking for a particular value, okay,
Mhm.
in which page it is there, it is going to show the address.
Okay.
See, every data is having address in the system. Yes or no? So
Right.
let's say
Yeah.
place a file where it is placed in so and so drive, in so and so folder, it is sharing in front of you. But when it comes to hard disk, hard disk, you know how hard disk works? Now everything is a flash disk, okay? But generally, hard disks are arranged like this. This is your hard disk, inside hard disk. These are the plates where you have magnetic coating to store the data, and there will be a spindle here to read your data. And this based on your data set, if it is here or back of the disk or this disk or back of this disk or this disk or back of the disk, there will be a read write header where it will read the data. Okay. Even it will write the data. Now, where it is going to write, where it is going to read is this is your disk. You might know your compact disk, right? Compact disk, DVDs.
Right.
So let's say this is your disk. Your disk is like this, whether it is a compact disk or DVD disk. Approximately just thick. Like this, there will be a lot of circles. This how whatever you seen in the disk, right?
Right.
Right. So whenever you place this in the CD drive, what happens? This disk is categorized into sectors, multiple sectors. Okay. This is the place where data gets stored. Even hard disk also same, okay? Similarly, then it will store here, then it will store here, then it will store here, then it will store here. Then it will go to here, then it will go to here. Okay. So how it is going there is with the help of this read write head. Now this is how it will write the data. Now you are looking for the data which is already there in the disk. This data. So what it will do, it will rotate accordingly and point your read head to particular place so that you can read the data. Okay. Got it?
Yeah.
This is how hard disk gets stored. Hard disk also now according to us hard disk is like this. Okay. Drive, folder, file. But for hard disk, it reads in a different way. You got it?
Yeah.
Yeah. Okay. This is internal. Actually, I told that why this how we search the data. Similarly, database also have its own mechanism internally. Okay. Any questions? Any questions? Please let me know.
No,
No.
sir.
Sir,
Any confusions?
no.
Okay then. So I'm sharing indexes what we discussed today. Tomorrow we'll continue on indexes left out topic.